Welcome to Tech for Novice channel dedicated to technology-related information in simple language. Thermography Part 1 and 2 deal with basic IR theory and Part 3 covers composing IR image. Please check the links below if you wish to watch. It is the fourth part in Thermography series dealing with thermal tuning, which is a process of enhancing image contrast for finding anomaly easier. We will explore thermal tuning tools and applications in this video. This video covers thermal tuning, second part of measurement techniques. It makes finding problems visually easier by highlighting target areas with higher contrast. Composing images, first part of measurement techniques, is covered in Thermography Part 3. If you own or intend to own an IR camera, or you are just curious about thermography, or interested in various technology, then this video is for you. Thermal tuning is the process of enhancing image contrast by adjusting colors using available analysis tools. This reversible process changes visual effects without influencing image data for temperature calculation. Pallets, isotherm, level and span are the tools used for thermal tuning. Palette is a set of colors or shades arranged for displaying different level of apparent temperature on the IR image. Different palettes have different level of contrast depending on the number and types of colors used. Changing color palette may change the IR image contrast as shown here. Color palettes usually use lighter color for hotter and darker color for colder sections. Inverted palettes reverse the color order using darker color for hotter and lighter color for colder sections. Inversing the palettes may also change the contrast. Isotherm is an equal temperature zone displayed with a contrasting color, green in this case. Isotherm could be either below or above certain temperature or interval of certain temperature with certain width. It highlights areas which have a certain apparent temperature range or areas below or above certain apparent temperature. Isotherm can be used to locate hottest spot on the image as demonstrated here. Select an interval isotherm with narrow span and move it up and down on the color scale bar until isotherm area on the image is smallest. Its location is the hottest spot. IR camera saves image data for the whole temperature range irrespective of the display settings. This image is currently displaying plus 36 degrees Celsius to plus 126 degrees Celsius, but it has data for minus 20 degrees Celsius to plus 150 degrees Celsius, which is the camera temperature range used to save the image. It is possible to display the image from minus 20 degrees Celsius to plus 150 degrees Celsius at the cost of losing details as number of colors available are distributed across 170 degree width instead of current 90 degree. Difference between upper and lower limits of the temperature range displayed is called span, 90 degrees Celsius in this case. It determines thermal contrast. Narrower the span, higher the contrast. The midpoint of the span, 81 degrees Celsius in this case, is called level. It can be changed by adjusting either lower or upper or both limits of temperature range with or without same span. Level is thermal brightness. Higher the level, higher the temperature of the region displayed. By adjusting both level and span, we can highlight the region of interest with increased contrast. Level and span are better thermal tuning tools than color palettes as they provide more control for improving contrast. Here we have three images, actually same image with different level and span. Obviously, image 3 has the best contrast due to smallest span. Most of the thermal cameras and analysis software allow to adjust level and span, which limits the apparent temperature range to be displayed. The color scale bar showing the apparent temperature range displayed on the image also shows 256 or less colors, or grayscale shades, distributed across the image within the span. Number of colors per unit temperature is increased with shorter span, leading to higher thermal contrast. Higher contrast makes detecting anomalies easier, which might be missed with lower contrast. It is an example of improved contrast by adjusting level and span. Second hotspot was invisible before the adjustment. Another example of improved contrast after adjusting level and span. Contrast could be improved simply by inverting the color palette in some cases. You may also check with inverted pallet or another pallet after level and span is adjusted. There is no temperature difference on the cup surface at the same height, but the white circles appear slightly cooler due to lower emissivity in comparison to yellow area. Let us see how adjusting level and span makes the small temperature difference obvious. Thermal tuning is necessary to find anomalies not visible due to insufficient contrast. IR image is actually a map of digitized infrared signal intensity received from target object. Difference in signal level is represented by 256 or fewer shades on grayscale image with brighter shades for higher intensity and darker shades for lower intensity. Color palette replaces each shade by one color. Each color shown on the color scale bar is actually an isotherm as it displays areas of certain temperature zone on the image. Multiple colors mean multiple isotherms. It is obvious with fewer colors in the palette as gradient is more noticeable on the color scale bar. This is an example of 30 color palettes with 0.33 degrees Celsius per color, same as 30 isotherms with a width of 0.33 Celsius each. Two examples. First, 130 color with 20 degree span, which is equivalent to 30 isotherms with 0.67 degrees Celsius width each. Second, 110 color also with 20 degree span, which is equivalent to 10 isotherms with 2 degrees Celsius width each. Here both images have 20 colors but with different spans. 10 degree span is equivalent to 20 isotherms of 0.5 degrees Celsius width each, and 20 degree span is equivalent to 20 isotherms of 1 degree Celsius width each. Thermal tuning is a simple and effective diagnostic procedure for increasing image contrast. It makes finding anomaly visually easier. Anomalies not noticeable might be found after thermal tuning. It is also useful for highlighting objects of certain temperature range and finding hottest spot. Thermal tuning has no influence on temperature measurement as modifications are limited to image display, which is completely reversible without much effort. Thank you so much for watching. If you like this video, please comment, share, thumbs up, subscribe, and press the bell icon. Next video will cover calculating linear FOV and IFOV using Excel.